Welcome. We are the Meterrific team. Our team is comprised of Shiv, Blake, Madison, Michael, Raj, and Andrew. Our advisor is Dr. Shaoli Ma. We have been working towards improving the experience of finding street parking with a low-cost solution. Our solution is a clip-on device that can give existing parking meters a smart feature set. For simplicity, we will refer to our clip-on solution as a meter during this presentation.
Now, let's discuss project architecture. Here we see a basic overview for how we get from the parking meter to the app. So first, the LiDAR on the meter checks to see if a car is parked in front of it. If there is no car parked in front of it, then it would be available. The PCB then uses Wi-Fi to update the Firebase, and then the Firebase is going to relay the information on parking space availability to the app. In this diagram, we can see how the LCD gets updated. First, the server and the app update Firebase independently with information on parking space availability, payment information, and time remaining. Firebase is then going to use Wi-Fi to update the PCB, which is going to relay to the LCD what information it needs to display.
This is the custom-built housing for the Meterrific parking meter. It was specially designed and printed in-house to accommodate all of the Meterrific features. It has cutouts for the LED indicator, LCD screen, LiDAR sensor, and solar panel. Inside, it has feet to isolate the PCB from the housing wall, and a recess for the LCD component. The joint is designed to click together, but there are also holes for M3 security screws to be inserted. The exterior edge has been beveled for style. With more resources, the housing would be printed from waterproof filament and include a mounting bracket to attach to existing parking meters.
We will now go over the hardware design. This diagram shows the Meterrific hardware suite, which is comprised of the housing, printed circuit board, and all of the components that interface with the printed circuit board. This printed circuit board was designed from scratch by the Meterrific team and was fully manufactured by the team at the Hive at Georgia Tech. This housing was also designed by the team and was 3D printed at a team member's home 3D printer. I'll start by reviewing the power system, which includes the solar panel, charge controller, boost converter, and lithium polymer or LiPo battery. The solar panel is the main charging device for this system and outputs 5 volts, which is stepped down to 3.7 volts by the charge controller, which allows for safe charging of the 3.7 volt LiPo battery. The LiPo battery is then connected to the boost converter, which boosts its 3.7 volt output up to 5 volts, which is what our Arduino Nano microcontroller needs for safe operation. The second system is the control system, which is comprised of the Arduino Nano microcontroller, the LiDAR sensor, the Wi-Fi module, and a status LED, which is a visual replacement for the status LCD. The Arduino Nano is the main control device for the system and handles all logic operations and I/O interfacing. It communicates via I2C and UART interfaces with the LiDAR sensor and Wi-Fi module. The firmware which controls the operation of the system runs on this device and was developed by the Meterrific firmware team. The LiDAR sensor acts as a range-finding device for this system and allows the system to tell whether a spot is available or taken. The Wi-Fi module allows the system to communicate with the team's Firebase server and update spot availability for a given parking meter. It also downloads a running timer to track time remaining for a parking spot. The status LED simply turns on to indicate that a spot is taken and turns off when a spot is free. The power system and the control system are routed through the printed circuit board to create a compact and reliable hardware suite.
We will now go over the app functionality. When you open the app, you're greeted with the login page. Let's create an account first. So I've entered the email and password to create an account. Let's register. Account's been created, so let's go back to the login page. I've entered that same email and password, so we can log in now. Here we see the dashboard. We have 2 options, navigation and transaction history. Now let's go over to the navigation page. The blue car icon represents our current location. The blue marker represents a parking meter which is still available and has not been taken yet. A gray marker represents a meter that has been taken by another car. We can click on any one of the parking meters to try to navigate to them. If we click on a gray one, it won't let us. If we click on a blue parking meter, it will allow us to navigate to that parking meter. If you click navigate, you will get a turn-by-turn directions to your parking meter, as you can see here. So I want to navigate to a mall close by. I can enter its name at the top of the search bar and click submit. The name can be entered in just the plain value, it doesn't have to be typed out as an address. Once I click submit, it starts navigating us to the destination and then selects the closest parking meter to our destination. In this case, it was the middle parking meter. Now what happens if that parking meter becomes unavailable as we're navigating to it? As you can see, that parking meter turned gray and we were instantly rerouted to the next closest parking meter to our destination. Now let's say we're about to reach our parking meter. The second the system detects that that parking meter has been taken and our car is close enough to the parking meter, it will ask us to pay for that meter. A pop-up came asking us to pay for that meter. We can click pay now to go to the payment page. Here we're presented with 4 options of how long we would like to reserve the parking meter for. We can reserve the parking meter for 30 minutes, which would cost a total of 50 cents. And we can click the pay now button to pay for our parking meter. Once you've paid, you're brought back to the dashboard where the navigation button has been replaced with the status of the current parking meter. As you can see, it says we have 30 minutes remaining, and the LCD panel of our parking meter also says we have 30 minutes remaining. Let's skip ahead 30 minutes. Now we can see both on the panel and the app that we're almost out of time with 0 minutes remaining. Once the time runs out, we will be able to navigate again. Now we can look at our transaction history and see that the transaction we just made has appeared here. There is one more feature to the app which can only be accessed by admins. We can assign this user to be an admin through Firebase. Once they're assigned an admin, they are able to see the option to add a meter to the map. Here, the admin will have to fill out all these categories in order to add a meter to the map. I filled out all the attributes, like the address, the latitude and longitude, in order to display the meter on the map. The start date time and end date time are when the meter is available from 6 a.m. to 7 p.m. The cost for 15 minutes field dictates how much the meter costs for 15 minutes, and the max minutes is how long the meter can be reserved in total. We can add this meter, and it says we have added it. We can go back to navigation, and here we can see that we have added the meter below us at the exact address we specified.
We will now be showing the app working in conjunction with the parking meter add-on. A user has opened the app and is now ready to navigate. After clicking navigate, a map populates with an open parking meter. The user selects this parking meter and chooses to navigate to it. Once this is done, a route will appear and the user will be on their way to the parking meter. As the user approaches the destination, their location will be updated on the map. When the user arrives at their destination, an alert will pop up on the map notifying the user to go to the payment page. Additionally, the LiDAR in the parking meter add-on will detect the car and an LED will change to red, indicating that the spot is now taken. The parking meter add-on will then use Wi-Fi to update the Firebase and change the meter's availability from 1 to 0. The user has selected the payment page. Once at the payment page, the user can select the amount of time they want to park. Once this has been selected, the user is returned to the dashboard page and notified of their parking meter. The app will then update the Firebase to indicate both the time remaining on the meter and the user who purchased it.
To recap, here are the features of our solution. Our solution is an easy-to-install model, meaning it can be attached to any single-spot parking meter without removing existing infrastructure. Real-time availability allows users to find open spots faster and save a trip if parking spots aren't available. This feature emphasizes our goal to reduce wasted gas and time. We have built-in navigation, so users can reach their destination without the hassle of making sure they're at the correct parking spot. Automatic rerouting will take users to the next closest parking spot if one is taken before they arrive. Contactless or online payment allows users to increase the reservation time from wherever they are and prevents the spread of germs, especially in light of COVID-19. We would like to acknowledge Dr. Ma for advising us through our project, Professor Smith and Dr. Frazier for facilitating our project during ECE 4012 Senior Design, and finally, Maria and Sean for helping us record our street side demo.